All right, guys, are there any questions over any of the assignments thus far? Any questions over any of the assignments thus far before we start the lesson today? Okay. So what we're looking at today is deductive reasoning. Now, inductive reasoning was looking at situations or using patterns to make a statement. Inductive is patterns. Deductive is going to be facts. We're using facts, laws, logic to form a logical argument. This is different from inductive reasoning, which uses specific examples and patterns to form a conjecture. Inductive, we're using patterns or observations to make a conjecture. Deductive reasoning, we're using facts, definitions, accepted properties, and laws of logic to make a statement. So deductive is facts, inductive is patterns. Now we have two specific laws of logic. One of them is detachment, law of detachment. And the law of detachment states, if the hypothesis of a true conditional statement is true, then the conclusion is true also. If we can say that the hypothesis is true, then the conclusion must be true. Now the law of syllogism, if hypothesis P, if hypothesis P, then conclusion Q. And we have if hypothesis Q, then conclusion R. If we have these two statements and both of them are true, then we can say if hypothesis Q, P, then conclusion R. I want one more. So with law of syllogism, if I draw markers everywhere. If P, then Q. If we have if P, then Q. If P, let's get a highlighter. If P, then Q. We have this statement. Then if Q, then R, where the conclusion of one and the hypothesis of the other match up, we can combine them by dropping out the one that's the same to match up the two others. So we have if P, then Q, and if Q, then R. If we have the hypothesis of one and the conclusion of the other match, we can combine the two statements into one to say if P, then R. Questions on this so far? Okay. Let's look at this one here. So example 4, use the law of detachment. So looking at this here, if two segments have the same length, then they are congruent. This here is our general statement. Whenever we use law of detachment, they're going to give us a statement. They're going to give us a fact. If two segments have the same length, then they're concluded. Then they are congruent. You know that BC is equal to XY. So what's that saying? That they are what? They have the same length, yes? Because when we don't have the line above it, we're talking about the segments length. So we're saying that BC's length is the same as XY, yes? What was our first statement that they gave us? If two segments have the same length, then they are congruent. According to the law of detachment, what do we say? If the hypothesis of a true conditional statement is true, then the conclusion must be also. So the hypothesis is that two segments have the same length. So what does that mean? They are congruent. So we're saying what? That BC is congruent to XY. Because according to the law of detachment, if the hypothesis is true, then the conclusion must be true also. Questions on this here? Yeah, line segment BC is congruent to XY. If a figure is a square, then it is a rectangle. So that's the statement that we were given. This is our starting statement. If a figure is a square, then it is a rectangle. You know that quadrilateral ABCD is a square. So is that telling us that the hypothesis of this statement is true? Because what's the hypothesis? A figure is ABCD a square? Yeah, so what can we say? The conclusion must also be true. And what's the conclusion? So ABCD is a rectangle. If the hypothesis is true, then the conclusion must also be true. Questions on this here? Because by definition, a rectangle has four right angles. And that's it. By definition, a rectangle is a four-sided shape with four right angles. A square, by definition, is a four-sided figure with four right angles and four congruent sides. So a rectangle just has four right angles. Yes. And we'll get into those, especially when we start talking about polygons and the properties of polygons, guys. Up here, focus up here. Thank you. If today is payday, then you will get paid. So that's our statement. If you got paid today, using the law of detachment, what can we say? If so, our main statement, if today is payday, then you will get paid, yes? If you got paid today, what can we say? So what's our hypothesis? If today is payday, yes? Is this telling us that the hypothesis is true? What's the hypothesis again? Today is payday, yes? Is me getting paid today saying that the hypothesis is true? Can I say anything from this? No. We can't use the law of detachment for this here because, again, the law of detachment states if the hypothesis is true, then the conclusion must also be true. You getting paid today isn't connected to the hypothesis. It's connected to the conclusion. So what statements can you make? You can't. There is no statement. Because, again, for us to use the law of detachment, the hypothesis must be true. Any questions on these here with law of detachment? So what we're looking at next is law of syllogism. Now the law of syllogism, really what we're looking for is a hypothesis and conclusion to match. We need a hypothesis of one to match the conclusion of the other. So what it tells us is this here. If x squared is greater than 25, then x squared is greater than 20. If x is greater than 5, then x squared is greater than 25. Do one of the hypotheses and one of the conclusions match with these two here? These two here match. X squared is greater than 25, yes? if we have one that matches in both, what we can do is we can take these two statements and make them into one. And what we'll do to make them into one is that we drop the parts that are the same and attach the others. So if what? Greater than 5, then that's it.
Why didn't you use the x squared on the bit?
Instead of putting the x squared is greater than 25 in the middle, you just drop it.
Because it's true in both. Since it's true in both, we can attach the other two together. Because if a conclusion of one matches the hypothesis of the other, then we can put the other two to make a single statement.
Oh, so basically you don't use like those two that are the same. Oh, okay.
Because if x is greater than 5, well, 6. 6 squared is greater than 25, yes? Well, if 6 squared is greater than 25, then, well, 6 squared is greater than 20.
I thought you were using like x2 greater than 25, like both of those to make sense.
No, we just need one of them to match. And x squared greater than 25 matches in both, so we can use the law of syllogism to attach the other two. Let's look at this one here. If a polygon is regular, then all angles in the interior of the polygon are congruent. If a polygon is regular, then all its sides are congruent. Do we have a hypothesis and conclusion that match? So the hypotheses are the same for both of these here, yes? Do I have a hypothesis and conclusion that match?
All sides are congruent, all angles.
Well, our angles and sides are the same. So do I have a hypothesis and conclusion that match? No. So if possible, is it possible? So this is not possible. Because again, we need a hypothesis and conclusion that match, that are the same. So this here.
Oh, so we can't do it if two of the hypotheses are the same.
Well, that's just saying the hypothesis is the same for both. It's not matching up.
Okay, so actually this makes sense.
Now, what can you conclude about the product of any even and odd integer? Well, is this going to be, guys, is this going to be inductive or deductive reasoning? What can you conclude about, what conclusion can you make about the product of any even and any odd integer? Well, we can use inductive because we can take several steps. We can look at patterns. We can take examples. Thank you. So 2 and negative 2, negative 2 and negative 4, 1 and 2, negative 1 and negative 4. And we can multiply them together to see that any even integer multiplied by any integer is an even integer. And it works out anytime we multiply an even number times another number, it's going to come out to be an even number. And we used examples to come about this and find it. Now, we can also do this by deductive reasoning. And a lot of proofs use something like this here. Let n and m each be any integer to show that this is true. So n and m are just any integer, any number. So n plus 2 times m. Because I know if I add 2 to a number, it's going to make it even, no matter what the number is. Or, sorry, not adding 2. Because we can say 2n is an even integer because any integer multiplied by 2 is even. No. 2nm represents the product of 2n and m. So, sorry. Just, you guys can watch. So, n and m are two integers, yes? If I multiply a number by 2, it is going to be even, yes? So I can say 2n is an even integer. And what we're looking at is the product of it times any other integer, m. So we have an even integer times n, yes? Well, if I multiply these together, I get what? 2n m, yes? Which is the same as 2 times nm. 2 times n times m is 2m, which is 2 times what? N times m. And what is n times n? That's just any two integers, yes? So really just saying that the product of 2 times this is going to be an even number. Yeah. That's it. I mean, this is using facts. But that's it. And really using facts or either one of these here is what we'll do, because inductive is using examples, deductive is using facts. But on a whole, we won't do too much with using actual proofs with inductive and deductive in this sense. We won't really do this here. But the last thing I believe we're going to be looking at is comparing inductive and deductive reasoning. This is going to be, I believe, the last part of this here. Now, looking at this here, decide whether inductive reasoning or deductive reasoning is used to reach the conclusion. Explain your reasoning. So, A, each time Monica kicks a ball up in the air, it returns to the ground. So the next time Monica kicks a ball up in the air, it will return to the ground. Is this inductive or deductive reasoning? So what do we think, guys? Inductive or deductive?
Deductive.
So what fact are we using?
The fact of gravity.
Does that what that says?
No.
What does it say?
It's a pattern.
Because every time Monica kicks the ball up in the air, it returns to the ground. So the next time Monica kicks the ball up the air, it will return to the ground. Is this using a fact? No. What is she making her assumption on?
Patterns.
A pattern. So this is because it's inductive. It's not going to be deductive. Because what is deductive?
Having multiple things and going through one by one.
Deductive is facts.
Like for say,
Facts, definitions. Yes. Let's look at the next one. All reptiles are cold-blooded. Parrots are not cold-blooded. Sue's pet parrot is not a reptile. Yes.
I don't know, man, not parrots are reptiles.
This is. Guys, let's focus in.
Reptile, parrot,
Guys, focus in. So, deductive, because again, they gave us a fact. All reptiles are cold-blooded. Parrots are not cold-blooded, so Sue's pet is not a reptile, because they gave us a fact. Questions on this here? And that's it.